So one of the reasons I built the Hydrata platform was to help us better manage change within our catchments. And today I'm going to show you what that looks like in practice. So here we have an existing hydraulic model of a small catchment. It's mainly residential, and you can see from the velocity mapping here pretty well defined flow paths through the catchment with water flowing from north to south. So we're going to run a simulation where we propose a new sports hall on a piece of parkland up here and see what kind of impact that might have on this flow regime. So firstly, let's go ahead and clear up the map a little bit and turn off the existing results. Now, to define our new project, I'm going to go ahead and create a new layer here. I'm going to call it buildings. Let me save that. And then we will add a new building. If we zoom in a little bit here, what we're going to simulate is putting a new sports hall in place of this park, which would be a large concrete slab. So to do that, I just go ahead and draw the footprint. Like so. And then I'm going to call this sports hall. Of course, this is a hypothetical example. You can see our new building footprint. Now, in order to assess how that might change the flow results, we're going to go ahead and create a new scenario. So here we already have our existing scenario defined. I'm going to create new scenario. I'm going to call it proposed. And we're going to set everything exactly the same as the existing situation, with the exception, of course, that in the proposed scenario, we're going to include our buildings. I'm going to click the build button here, and that will assemble our new scenario ready for modeling. This is going to take 2 minutes, so I'll pause the video and come back in a second. Okay, after about 30 seconds, that model is built, and we can check the log here, and we've got 1.5 million triangles in our mesh. So now I'm going to go ahead and run that model so that we can compare the existing to the proposed. And once again, I'm going to pause the video because this will take up to about 30 minutes for this model to run. Okay, well, I've had my cup of coffee. It's about 20 minutes later, and our model has run to completion. You can see the logs here. Let's have a look at some results. So now you can see that we have both existing and proposed results here. And I guess the first thing we would look at is the depth. So here's the building footprint, and you can see that there's a significant amount of water that's ponding behind the large concrete slab there, which isn't surprising, and we might want to compare that to the existing depth where you could see the water was flowing through the park here. So that gives us a bit of a rough idea of the kind of impact that our large concrete slab is going to have, but usually we want to be a bit more accurate than that. So what I'm going to do is select these two scenarios and hit the compare button. And this will go ahead and run a more detailed comparison between the two scenarios. Okay, and after another short pause, we're ready to look at the results in a different light. So now you will find that we have these comparison results here as well. So let's look at the difference in depth between our proposed and our existing scenario. And you can see the impact of the building footprint here is to have the ponded area shown in red. So these are all areas that are negatively impacted. And further downstream, because this footprint is retaining water, you find lower depth downstream, particularly in this existing detention basin. Now we can do a similar thing for velocity. And this will show you where we get some increased velocities as the water is concentrated around the edge of the footprint here. And of course, reduced velocities where we have reduced flow down the middle. And the final comparison that we might want to take a look at is the depth integrated velocity, which is essentially a measure for flow volume. And you can see here quite accurately where the water was flowing previously, and now under our new scenario where it's going to flow. And you can see that this is quite a valuable planning tool in assessing new development and managing the change in our catchments as they become more developed and land use changes, and we build new and interesting and different things. Hopefully that's been valuable to you. If it sounds interesting, I encourage you to log on to hydrata.com, create yourself an account and get involved. Thank you.